Hello, I'm Bukola Joseph, the physics enthusiast. So we are going to be solving quantum physics. Let's read the question together and then we'll tackle the problem together as usual. I read. Is psi given by psi is equal to a exponential ikx plus b exponential minus ikx and eigenfunctions of operator px? Give reason for your answer. So let's solve this problem together. So the question says that is psi an eigenfunction of the operator px? Now, this px you are seeing, the px is a momentum operator, okay? It is a momentum operator and it is given by, we have px is equal to minus ih cross d dx, okay? So for us to figure out this, for us to be able to know if psi is an eigenfunction of the operator x, we are going to be multiplying the momentum operator px by a wave function. Okay, so what does this mean? It means that we are going to be multiplying this eigenfunction by this momentum operator, okay, by a wave function psi. So if we multiply this by psi, we have this. We have h cross d psi dx. Okay, but we are given psi is equal to a exponential ikx plus b exponential minus ikx. Okay, so now we are going to differentiate psi with x so that we can find this, right? We'll differentiate this with x. So we have the psi dx. Okay, since psi is 0, we'll be substituting psi here. Okay, we'll replace this psi with what we have here. So it becomes d dx a exponential ikx plus b exponential minus ikx. Okay, so to differentiate this side with respect to x, we'll have this, right? This becomes the coefficient of x, okay, will be multiplied by everything. So we have ik, this is the coefficient of x. So we have ik times everything. We'll multiply it by everything here. So we'll have times what? A exponential ikx. Okay, then the coefficient is minus ik, so we have minus ik, then multiplied by everything, we have b exponential minus ikx. Okay, so we have differentiated psi with respect to x, and this is what we have. Let's further simplify. So if you further simplify, we'll have ik is common for the both momentum state. So we have a exponential ikx, right? Then minus what? B exponential minus ikx. Okay, so we factor out ik. Okay, so it means the psi dx is equal to this. So we are going to be substituting this into this. Okay, we'll substitute this into this. Okay, so if we do this, it becomes px psi is equal to minus ih cross, right? So we are substituting everything here. It becomes ik a exponential ikx minus, sorry, I'm going to clean this arrow, minus b exponential minus ikx. Okay, close the brackets. So we have this. So this becomes px psi is equal to, we have a minus here. I times I is minus 1. So minus minus, it becomes positive, and then we are left with what? hk. I don't know if you understand that. I times I is minus 1. minus times minus becomes positive, so we are left with what? HK. So we have HK A exponential IKX minus B exponential minus IKX. But remember, so it means that this is what we have now. We have PXI is equal to HK. All right, HK psi. Yeah, this is also psi. But look at the sign, okay? This one is negative and this is what? Positive. So for psi to be an eigenfunction, of the operator px, the psi on the right hand side must be equal to the psi on the left hand side. So looking at what we have, is not equal, okay, because the psi on the right hand side is positive, while the psi on the right hand side is negative. So it means that psi on the left hand side is not equal to psi on the right hand side. And so because of this, psi is not an eigenfunction of the operator px. Okay, now this is because psi represents a superposition of momentum states with opposite momenta. Of course, you know that the plural of momentum is momenta. Okay, so since it's opposite momenta, meaning that it means this is going to be like hk is equal to what? Minus hk. That's what it means. It's not hk equal to what? Hk. And I hope you remember that the momentum operator was multiplied by what? A wave function psi. I hope you enjoyed today's problem solving. I'm Bukola Joseph, the physics enthusiast. Bye.